Good morning. Welcome to the Cambridge Power Platform User Group. We are in our spring event, albeit it's 40 degrees outside. Let's ignore that summer sneaking up on us a little bit too soon. But the spring sessions, we've decided to have a week of events. So yesterday we did a fantastic panel with Zoe Wilson, Douglas Romano was there, and also Sean from Zen Zero, who's a newcomer to the group. And we discussed AI and how things were building within the Power Platform. Well, today we're going to get deeper into that tech. We have the lovely Clarissa Gillingham with us, and today's session is going to be a real doing session, a demo session. Who doesn't love a good demo? So let's show you what we've got on the agenda for the full week. Oh, we'll do a quick intro to me first in case we haven't met. Hi, my name's Sharon Sumner. Lovely to meet you. I run the Power Platform, although there's several people in the background who I'll introduce you to in a moment. I'm also a Microsoft MVP, have been for 6 years, I think now, and a regional director for about 4. I specialise in business applications, although really SharePoint, as everybody knows me, is SharePoint Sharon. In the background then we have the lovely Sancho Harker, MVP, also a business applications MVP. I'm happy for you to come off mute if you want, Sancho.
Morning.
There he is. Looking after questions in the chat, doing some moderation for us. We also have Luke Drew McKay from my team. Luke, where are you?
Hey, folks.
Who is dealing with all of the technical mastery behind putting these events together all week for us. So thanks very much to Luke. He's also in the chat helping out with any technical difficulties. And also on the call is the lovely Amber Turner Smart. Amber, are you there?
Hello, hi guys.
Amber will have been responsible for contacting all of the speakers and bringing this whole thing together for us so that it works seamlessly. So that said, those people in the background are here to be respected as professionals in the same way that Clarissa and I. Please, if you do put information in chat or if you come off mute, please do respect the code of conduct and generally be nice. This is the week's agenda for you. So as I say, yesterday we did the AI in action, and today we have user-defined functions in Power Apps. So we're going to get right into it in a minute. Tomorrow we've got Leslie coming to see us to talk about adoption, really important, especially based off yesterday's conversation. And that will be available to watch on YouTube. So do watch it back and see what was said. We've also then got Douglas doing a little bit more of a deep dive again, but using Claude with the Power Platform this time, which is a nice angle. And then we're rounding off the week with a roundtable, as you do, talking about women in tech and kind of where we've got to on that, where we're at so far. And so we'll have Clarissa back for that, and also Zoe, who was in the first session with us, who is one of the senior leaders at Kindle. Okay. Back to today. Clarissa. So Clarissa, I've known Clarissa for some time, but let's introduce her to you. Clarissa is a very well-seasoned Power Platform professional, alumni MVP, so also recognised by Microsoft too, and now actually works for Zen Zero in my team. So I get to stay and play with Clarissa quite a lot on the Power Platform, and I can tell you she's very, very good at what she does. But let me pass over to you, Clarissa, to introduce yourself and to take over the session. Have a good one.
Oh, thank you very much. First, thank you very much for having me on the event, and also having me in your team. We'll throw that one out there. But yeah, no, as Sharon said, I've been working with Power Platform for a long time, specializing in Canvas apps in particular. So just to give you a quick little taster, I guess, of the kind of thing that I'm generally known for is creating like kind of fancy UIs. Hopefully it's always a bit nerve-wracking when you introduce something and say that you think it's fancy. Hopefully the audience agrees, but we've got things like, you know, collapsible, expandable menus, some nice kind of notification feeds, conversation threads, and everything being all like, you know, responsive and all that sort of thing. So this is kind of what I'm mostly known for in the Power Platform space. And I really try and push the boundaries of not just from the aesthetic side and what's possible within Canvas apps, but also from a functionality perspective. And it's that functionality perspective that we're going to be diving into today. Obviously, as Sharon said, we're going to be talking about user-defined functions. We're also going to be, it's a very doing session, so there's no decks whatsoever. We are in the studio, we're getting in there. But first, before we start getting into the weeds of actually showing you some code, showing you some functions, I want to talk about what functions are, because it's important to recognize, obviously, Power Apps, Canvas apps, we talk about these being low-code tools and available for people who don't have a professional development background. And so it's important that we all are on the same kind of playing field when we're talking about these concepts. So what is a function? Well, a function can be thought of as kind of like an isolated bubble that is able to take things in and perform some kind of action, whether that's performing a calculation or actually doing something in our application. Functions are almost like, it's like a black box in a way. You can think of it as like a factory. You don't need to know how the factory takes eggs, flour, and sugar and spits out a cake. All you need to know is if I give my factory eggs, flour, sugar, then it will spit out a cake. So that is how functions can be kind of thought of, is this, it's that factory element that performs intermediary actions that take inputs and then provide an output or do something in our application. So you've probably been using functions in your Canvas apps every single day. Even something as simple as, let's just throw something in here. Even as something as simple as the function today. This doesn't actually take in any inputs. So we find out that functions don't actually necessarily need to take in inputs. But what it does is when we ask it to do its job, it tells us what the date is today. So this also allows us to think about the fact that functions, it's something that we can ask to do a job for us. So whenever we need to find out what the day is today or present that to the customer who's actually using our application, we don't need to do some kind of complicated logic to work out exactly how much, exactly what the date is today. We can just use the today function, which already has all of those necessary steps to work that out inside it. So what other kind of functions do we use every day? Things like the date add function, for example, we can throw in today and we can ask it once. So what we're doing here is we're now throwing inputs into this function, this factory, and we're saying, okay, for today's, what we want to do is we want to add one day to today. Now, you might be thinking, how do we know what to throw into these functions? And this is where there's a really useful reference that we can use. So if we just look for Power Apps formula reference in good old Google, we can bring up the formula reference for Canvas apps. And immediately you might be wondering, hang on a second, Clarissa, we were talking about functions and now you're talking about formulas. What's going on here? So there's a little bit of a nomenclature kind of conflict. So because of the way that Power Apps was initially developed and where it came from, it originally kind of was inspired by and fed by Excel. And in Excel, we think of things as having formulas. So you use like the sum formula to sum columns in an Excel table. But the names are essentially interchangeable. I mean, you can even see here, we start off the article saying formula reference, then it goes, this article explains all the functions, and then formulas, and now we've got functions again. So you can kind of think of them as being interchangeable in this respect. So if you do end up getting some kind of confusion around what's the difference, here we can just think of them as the same. So in this reference, we can look for things like all of the different functions that are available to us within Power Apps. And these are functions that Microsoft have made for us that we can then use in our Canvas apps to create whatever business logic we need. So if we scroll down to what we've been just looking at now is the date add function, we can start to see how this function is meant to be used. So there's a really useful part in the documentation called syntax. And that might sound like a scary word, but all it really means is grammar. So it's like when you're constructing a sentence in English, you need to know where to put your commas, where to put your full stops. If you are making a question, you need to put a question mark at the end. This is all that's kind of the equivalent in code of syntax. It's just where you put your information, the order you construct your sentence, as it were. So this tells us exactly how to use this function. We start off by writing the function name, and then what we do is we open some brackets. You can see those here. And inside those brackets, we put our inputs into the function. So if, as we were talking about that kind of factory analogy, we would have like the name be make cake, brackets, X flour sugar, close brackets. And hopefully it would spit out a cake for us. So this is a really useful reference and tool to understand how to use the functions that Microsoft have already provided for us. So we can see the first thing that is required is a date time. So that's anything that is a day or a day with some time component to it. So by throwing in today in our function here, what we're saying is we want you to perform this. The first argument of our function, the first input that we're putting in is the current day today. And this kind of shows as well that what you can do is you can use these functions together. You can chain them. We're actually using a function which is outputting a value and using that output as the input of another function. So we can kind of chain these factories together. And all we're doing is we're adding the number 1. We can also see when we hover here that after clicking today, we can see that today is of type date. So this is a really useful kind of terminology to get to know is data types. So not only do we have in our function what needs to go in, but we need to know what kind of shape of that thing that we're putting in needs to be. So what we say in the formula reference is it requires something that is either a date or a date time value. We'll get more into the weeds on data types later, and I will explain that a bit further in a minute. So obviously we can do loads of different things with these functions, and you've probably used loads of them. We can well, there's a whole massive list of functions that we can use here. Not only date add, we could use date diff to find like the difference in days between 2 events. But what if you wanted to do something that isn't provided by the functions that Microsoft have made for us? What if, for example, rather than using date diff to find the number of days between now and Christmas, hopefully many days away, we wanted to find out the number of working days between now and then? Well, that's not an option with the functions that Microsoft have provided us. What if we wanted to do something that was really specific to our business case? Well, Microsoft don't know the ins and outs of all of our businesses. They're not going to be able to provide us functions that are specific to our business and our business needs and our business data. What do we do then? Well, what we tend to do is have really complicated functions inside, really complicated series of function calls inside, say, a label control or a button control in our application. And we end up with things that are quite bloated and can be very confusing to then use and read, and also very confusing to maintain. Because if you're doing something which is kind of like a core bit of your logic and functionality, and you need that in multiple places in your application, then as soon as you need to update that, you've got to remember everywhere where you copied and pasted that information. And I'm sure if you've been using Canvas apps and making more complicated applications, it will be familiar to you, this concept of needing to copy and paste your code in different locations. And obviously, as I say, that becomes a maintainability nightmare. And it also becomes a risk, because as soon as you forget one specific place to update, then that means that you might be having bugs, you might be having data not going through the correct processes, you might be having situations where people who are relying on your application to help them with their work are now unable to get the right data output or get the right process kind of going through for their situation. So how do we fix that kind of situation? Well, luckily, very recently, Microsoft have provided us with a means to finally solve that problem. What we can do is we can define our own functions. And that's what user-defined functions are. They are functions that we basically stipulate what happens, the steps that happen inside the factory. We say, okay, we want a function that is called this, that takes in this, does these steps, and outputs that. And then whenever we need to use that functionality, we can just call that specific function in our application. That's a lot of words. Let's actually see it in practice. So to start off with, we're just going to start with a nice kind of simple case. Let's imagine we have a situation where we maybe we're an educational institution, we're trying to look at grades of people taking some tests, and we want to convert their scores into percentage values. So say, you got 5 out of 10, you get 50%. There isn't something in the formula reference that, the Microsoft provided functions that can do this for us easily. So let's try and make our own function. To start off with, we're just going to throw some stuff on the screen. So I'm going to call this text score, and it's on the workshop screen. And we're just going to get rid of that default text, and we're going to make sure that it can only bring in numbers. There we go. And let's throw in another one for the max score. And the first thing that we're going to do, and this is the steps that I take when I'm creating these functions, is rather than try and create the functionality and convert it into a user-defined function in one go, is create the functionality, test that it works on the screen, and then convert it into a function. So what we're going to do is we're going to introduce a label, and let's just write some numbers in here. Let's go with that 5 out of 10, because we know that that should be 50%. And let's try and make our code, just write it so that it would work, forgetting about user-defined functions to start off with. So in order to convert a score into a percentage, what we need to do is divide the score that they got by the maximum score and then multiply that by 100. So let's just do that. We've got our score. We're going to divide it by our maximum score. And we're going to multiply that by 100. And now we should see this says 50%, it says 20%. Perfect. It's working as expected. So now let's think about what this calculation is doing and how we can turn this into a reusable function. Because at the moment, obviously, this is bound to those text inputs that we put in. It's bound to this and this, which means that if we wanted to try and use this in another screen, then it's not going to work. Or if we tried to, have multiple inputs, and it's not very useful in that respect. But it was very useful for us for testing. So what we need to think about is we've got what our calculation is, what our factory does, and we know what our factory outputs is the percentage value. But what inputs do we need? What are the bits of this calculation that can vary? And those bits that can vary are variables. And that's all that the word variable means, is just something that can, a value that can vary. And those will be our inputs into our function. So what I find really useful now, obviously this is quite a simple case, so it could be a step that you could skip. But what I find very useful is using the with function to prototype my user-defined function. So what I'm going to do here is I'm going to use the with function to separate out the variables from the calculation, just so that in my mind I've got that nice plan of these are the things that can vary, these are my inputs, this is the calculation, and I know what it's going to output. So our first thing, that is our first variable, is the score. Obviously, if you've got 100 people taking a test, they're not all going to get the same score, so that's going to vary. So we'll just pop in the score value in there. And do we have anything else that varies? Well, obviously, if everyone's taking the same test, then the max score is going to be the same for everyone. But what if we've got multiple different tests going on? Say, our first one has 10 questions, our second one might have 20 questions. So the maximum score is also going to vary in future. Even if for our exact specific scenario that we're writing right now, it might not vary, because if we're just looking at one test, it might not vary right now. So this is also an important exercise in thinking about, how this functionality is going to affect things in future, or is it, how this function can help not just what you're doing right now, but what you might be doing, what your business might be doing in future as well, or what other people in your business might be doing. So now we've got our variables as they are. So let's put those into our calculation. So our calculation now relies on our variables.
In the test.
Fantastic. So did we, right, so yes, that means that because we can have multiple different results, or we can have multiple different numbers of questions in our test, then both the actual score that people can get and can receive, and the maximum score that they could achieve in a test is going to vary. So both of those things we want to be variables. We want those to be inputs into our function, so that our function can be used not just for one test, but could be used for any test in future. So now what I've done essentially is I've just popped the actual score that they get, and also the maximum score that they can receive into these kind of temporary variables that the with function allows us to use. and then made sure that our calculation is referencing those with variables rather than directly going to those text inputs. And we'll see a bit more as to exactly why that's useful in a moment. But one of the reasons why I like doing it this way, I follow this process and like to see, prototype my functions with the with function like this, is that at any point I can see that whether my calculation is working, whether it's going to be giving me the right output. We've made our changes and we can that it's, as expected. 10 out of 15 gives us 66%. We can see that if we change this to 30, we get 33%. We also get this interesting error, which we're going to touch on later. But using this method allows us to always make sure that we are happy with our code, our actual functionality of our code, before we try and then convert it into a function that we can use anywhere. So what we're going to do is we're going to press all the right buttons instead of those ones. We're going to copy that text and we're going to look at where we can actually define this user-defined function. Because we've been doing what we're used to. We've been putting our code in the properties of our actual controls that are on our screen, but it's not just our controls that can have properties or our screens that can have properties. Our app actually has properties as well. You might, if you've been using Power Apps for several years, you might have been used to coming in and changing the onStart property and actually, creating logic in there, which is, something that we don't do now for performance reasons. But what we do have in here and what we can make use of is the formulas property. And this again, we've got that confusing nomenclature between formulas and functions and everything kind of being a bit blended, but this is where we come. So what can we put in our formulas property? Well, this is where we can define our user-defined functions, but it's also where we can define what's called named formulas, which are a sort of global variable that are calculated when needed by the application. But for now, we're going to focus on putting in our user-defined function. And as with anything, what we need to know is the syntax of how do we actually define this function. And unfortunately, there doesn't seem to be much in the way. If we go user-defined functions in Power Apps syntax, then just threw on examples at the end. There isn't anything super useful like the Power Apps formula reference from Microsoft Learn about this. So you end up, obviously you can find some of the things from the AI summaries. There's also some blog posts, but there's nothing in the way of, this kind of documentation, which is a shame. Hopefully that will come in future. But these are the kind of resources that you can use to find out what the actual required syntax is, or you can learn from this video. So we'll pop that in now. Syntax for a user-defined function. So the first thing we need to do is we need to provide it with a function name. So what I would normally do is preface all of my functions with something like func, just so that I know that they are user-defined functions. You could do it as UDF, whatever kind of nomenclature or naming convention works for you is fantastic, just so long as you're consistent. That's what makes it really powerful. So you give it a function name, and then we open our brackets. So it's just like using a regular function that Microsoft have provided you give it the name, you open a bracket. And you can see that when you do that, it might be difficult to see through Teams, but the function name actually turns blue in exactly the same way as when we do like today or navigate. You know, that's the color that the IDE for Power Apps uses to indicate a function. So we do function name, and then what we need to do is provide the blueprints for our inputs. So the first thing we do is we write the name of our first input. What I tend to do is prefix this with par, which is short for parameter, because it's an input parameter. You could do it as imp or, you know, whatever kind of naming convention works for you. And then we use a colon. And you'll see that Power Apps actually brings up a list of all these possible things that we can put after the colon. So what are we doing here? What does this possible list mean? Well, this is defining the data type of our input parameter. So it can either be something like a text or a number, which is nice and easy to understand, a date, or it's got things like float, which might be a bit more unfamiliar to people. That's essentially a number with a decimal point. A Boolean is either a true or false value. So we can have multiple different options for what type of data we put into our function. And we spoke about this briefly before about how all data has a type, and that's kind of like almost like its shape. You can think of it as you know, those toys that you have for kids where it's the box with the different shaped holes, and you have to put the right shape into the right hole in order for you know, it to fit. Obviously your square is not going to fit through your circle hole. This is essentially what we're doing here. We're defining the shape of the hole so that when we try and use the function, it checks to see, okay, is this a valid thing that you're trying to put in? Are you trying to put a circle into the circle hole, or are you trying to fit a square? And if you're trying to put in a square, then it throws an error, just in the same way as if we were to come in here and let's just quickly do that. If we were to say date add cookies and cream, it's going to be like, whoa, what are you trying to do? Cookies is not a date time value. So this is what we're doing here. We're defining that blueprint of what is the shape of data that we need for our function. So this you would then put in your data type, and you can chain these number of inputs with a comma. So you could put in par input name 2, and that would be data type 2, so on and so forth. And then you would close your brackets. And I know this is a little bit of a kind of like, how do you know, how do you know these things? As soon as you've got this syntax down pat, this is what will allow you to kind of create these functions very quickly. So the next thing we need to do is we need to define the shape of our output. So again, we use a colon. So this is, you know, you can think of colon always being in this kind of context, always being the next thing is a type. So you've got your thing on the left and your type of it is on the right. And again, you'd put in a data type. And then finally, we put equals. So this is where we're defining what the function actually does. So the first thing is what the function's called. The next things are what the functions take in and what shape that data is. Then we define what shape of data we're pushing out. And finally, we put in what the function actually does. And we finish with a semicolon. Obviously, that's not actually going to work. So I'll just comment that out, but that provides us with the blueprint of, okay, this is how we build our functions. So as long as you've got one instance of this, you can always refer to that to then be like, okay, this is how our functions are actually going to be built. So now let's take our calculation of our percentage conversion and turn it into this format that we see in front of us. So firstly, I'm just going to drop I think I copied it before, there we go, drop our logic in here so that we can reference it. So we've got our 2 reference points. We've got our logic that we know works, and we've got our blueprint for the format, the syntax, that kind of sentence structure that we need to put this into in order for it to act as a function. So let's just follow through. The first thing we need to do is create a function name. So we're going to do func convert score into percentage. It's always good to give it something that's really descriptive as to what it does, and then we can start looking at our inputs. Now, because of the way that we did this with the with function and we prototyped our function on the screen, we actually know already what our inputs are going to be. It's going to be the score, and our score is going to be of type number, because we know that it's always going to be a numerical value, and our max score, which is also going to be a number. And in this case, what we're spitting out is also a number, because we know that the result of this calculation is always going to be a number. And then we can do equals, and if we want, we can even just copy this into here and just change our widths to pars to match our naming up here. And now we have a function that performs this job. So if we go back into our screen, we can now double check this works by just calling func, and you can see it's already PowerUps knows this is, you know, an available function for us to use. So we can click on that. It knows that the first thing we need to give it is parse score. Fantastic. We know that parse score is our text value in our score input. And then our next is par max score. And we know that that is our text value from our max score. And now we can test to see whether that's working. 10 out of 30, correct. Fantastic. This is doing exactly what we think it should. And we got that pesky error again. So now we're going to start to have a look at why does that error appear. So first, I should quickly mention, so now if we wanted to convert any other score in our entire application into a percentage, we can just call func convert score into percentage and input whatever score we wanted, whatever max score we wanted. It's not bound to a particular screen or any particular controls. And if we wanted to make a change to how that function works, we can make that change in the one place in the app formulas property rather than everywhere in our application where we're calling this logic, which might be quite a few places if you're presenting scores to, say, a whole cohort in an educational app. So the next thing to think about is, why do we get that error when we change this? When we take out that value for the max score, we're getting an invalid operation error, which is saying that we're trying to divide by 0. Now, you might think, well, why is it trying to calculate the percentage? Because we haven't actually given a max score yet. Why is it trying until we give it a max score? And this comes down to when the formulas are actually, when the functions are actually called. So the really smart thing about the app formulas property is that the PowerApps is able to detect when, say, these inputs changes, and then it knows that it needs to recalculate the percentage. So if we were to be doing this instead with like set and global variables, we would need a button press to like kind of say, okay, you know, when I change the values and I'm happy with them, press the button, recalculate, and then it will spit out the value. But what this is doing is it's dynamically being able to see within the application when these values are changing, when do I need to be recalculated. So these functions are essentially really, really useful because they are able to make sure that the value that they're putting out is always up to date, because no matter what is changing those input parameters, Power Apps is always able to catch that change and automatically recalculate the value without relying on us putting things in on-change properties, for example, or putting in buttons and things like that. So the reason that error happens is whenever we're changing this value, Power Apps is automatically trying to recalculate this function. So what that does mean is that we do need to be careful with handling error situations. So how do we handle this kind of error situation? Well, if you've never used it, there's a really, really useful function called if error. So if we, oh, that did not go where I expected it to. There we are. Let's come down to here and have a look at if error and the way that this works. And this is actually the example that they use for the use case of if error, is that kind of dividing by 0. So the way that if error works, and we can come down to the syntax at some point, but we can just see it up here, is it will try and do this first calculation. And then if that calculation would result in an error, rather than flagging the error, it will fall back to this value. So essentially, the result of this, if x is greater than 0, will be 1 over x. If x is 0, then it will always spit out 0. So we can use that in here. And let's just test, before we add it into our function, let's test whether it works as we expect. We can do if error, func convert score into percentage, 0. So that means if this would result in an error, just output 0. Otherwise, be happy to output this value. And we can now see, once we get rid of all the old error messages, but it's now saying 0. It's now saying the right thing. We're not getting that error message flash up anymore. Fantastic, we've resolved that issue. But as I'm sure you're aware, you don't want to be having to wrap your function in this if error all the time. What you actually want is for your function to include this if error capability. It's really important when you're creating functions to try and make sure that you add your error handling inside the function, so you're not relying on either other people or your own memory to think, okay, I'm using this function, I need to remember to wrap error handling around it all the time. Then you're still getting into that situation of needing to like kind of copy and paste things everywhere, which is what we're trying to get away from. But we've tested that this works, so let's actually add that into our application, into our function here. So we're literally just going to do the same thing, wrap our result in if error, 0. Perfect. And now when we come back and we again just double check it, it's always really, really important when you're making these functions to test the function at every single stage. We can now see that, yep, it's doing exactly as we expected. It's not erroring when we give it an empty value. Fantastic. And we can continue building on this function. So we might say, well, at the moment it's just spitting out a percentage value, but normally what we'll want is for this to actually be formatted as a percentage in our application for users to actually be able to see this is a percentage. So how we would do that in like just the regular label is something like using the $sign here, so that we can say, okay, what we want is a text string that has the result of our function followed by a percentage sign. And we can now see again that in action in our application. And we can see obviously that when we put something that doesn't neatly divide, we get all of those extended decimal places. So it might be tempting to immediately come in here and go, okay, well, fantastic. What I'm going to do is I'm going to change this so that it's no longer outputting a number, it's now outputting a text string, and I'm going to do exactly what I did in my label and just add the percentage. Fantastic. But what we're actually doing here is now we've got a function that is kind of no longer doing what it says that it's doing, because our function is converting a score into a percentage value. And what we're doing now is we're actually converting the score into a percentage, and we're formatting it as some text to be able to display that nicely to the user. And that might be useful right now, but what if in future we wanted to actually perform some calculations on those percentages? Say we wanted to work out the average. Well, for that, we want the percentage as a number again. So would we then create a different function, or recreate this functionality in a separate function? It's really useful when you're creating these things to make sure that each function is just doing one small thing, because you can chain them together to provide the kind of combined or compound functionality that you might want. So what I'm actually going to do, instead of doing it like this, is create another function entirely, which is going to be format percentage. And that's going to take in a percentage value, which is just a number, and it's going to output text. And we're going to do, well, let's do this nicely. Oh, no, sorry. It's absolutely fine to do it like this. There we go. Let's do par percentage. Just like that. Perfect. So now what we can do is in here, we can say, let's get rid of those. We want to use func format percentage. Our first argument is the percentage, which we can calculate from using our func score percentage value. Oh, what have I done here? Have I accidentally broken it? Let's just double check. Yes, I didn't get rid of those. There we go. Perfect. So we can do that. And now we get the same result of it showing the number and then the percentage sign, but we've also retained our ability to actually store that value as a number that then we can do some mathematical manipulation on in future. So let's have a look at how we would do something like that with like the averaging of certain values. If I just copy all of these and drop these down here, and let's just add in some fake values into here, just so that we've got something to work with. Okay, so this is going to be another example of like where it's really useful actually testing the functionality in the app screen first, rather than trying to write the function straight out, because what we might find if we try and write the function straight away is we end up in a confusing situation of what actually do we need to put into our function before we've actually worked out how our function is going to perform the calculation, whether this, whether our first idea is actually going to work out to create this value. So first off, we're going to have a look at how we can try and create this average. So if we think about the easiest way to do this, we know percentage value 1 is going to be the we can just copy it straight from here. Percentage value 1 is our convert score into percentage value of our first score text, and our first max score text. Percentage value 2 is the same, but for our copied variables, which we haven't nicely named, but forgive me for that. And then in order to actually get to the average, what we would do is we would add that to that and divide it by 2. Perfect. Now we've got a starting point. We know that this is kind of how we would get to this value in the simplest way possible. But this has a lot of problems, which you might already have noticed. Firstly, this is relying only on having 2 things to average, and we might end up having 3, 4, 5, 50, 100 scores to average. And what we really want is to have a function that is able to take any number of scores. So what we need to do now is manipulate this code so that we can get that same result of 23.333, but using different kind of manipulations of our data to make sure that we can have something that would work even if we had 3 scores or 4 scores and things like that. So when we're thinking of averaging or like summing across a variable number of rows, that immediately makes us think of tables. So what we need is something where we can put in a table of scores and then be able to output the average. So let's think about how that might look. Let's start off with our table of scores. So to create a table, obviously we'll use the square brackets to say that this is an array or a list of something, and we're going to put in some score objects. So each row would contain a score. First row contains the one from just our text score. Our next one is our text max score. And our second score is defined in the same way, but by the copied controls. Perfect. Now we've got this, how would we go about actually getting the average? Well, the first thing we want to do is to create like another column in our table that is going to be able to hold the percentage value. Well, luckily we know that there's another function available to us called add columns. That's exactly what we want to do. We want to add a column to our table, so we're going to use add columns to do so. And the table we want to add to is with scores. Column we want to add would be called percentage, and the calculation we want to use to actually populate that column for each is our function that we've just created of converting the score into percentage. So we'll do score max score, because what this will do is it will take the value from the score column and take the value from the max score column, input those into our function, and then output the percentage. And that will give us our next table. Now, obviously, at the moment, the output of what we're working on is not compatible with the text label that we're working with, but we can use the fact that we're using a text label, that we're prototyping this function in the screen here, to double check, to drill into, okay, at this stage, what have we got? Have we got something that makes sense? So let's just do a concat on that of percentage, so that we can see what the percentages actually are outputting, and double check whether our logic here is like whether our next step is on the right lines before we then go into the finishing that off, finalizing that to create the average. And we can see immediately immediately, hopefully it's big enough for everyone, on the screen we can see the first percentage has worked out correctly, the second percentage has worked out correctly. Excellent. We know that our function or our functionality, our code that we're writing, is on the right lines. So now we can take that out and we can have, say, let's put this in another width, the result of this. So we're going to say with percentages is that, and we just want to grab the percentage column from our table. And now we can start manipulating that stage. So I always like using the with function to like kind of separate out each step of the process. So it's really then easy to reread the code, to debug the code, to maintain the code. So what we finally want to do is actually do the average. So we would use the average function, and we want to do the averages of our table with percentages over the column percentage. And hopefully what we'll find is this gives us 23.3333, which is exactly what we first found the answer to be using our really simplistic method of, okay, let's just get a value so that we can test whether our code is going to work. Excellent. So now we have something that we know no matter what scores we put in here, this is going to give us the average. We could have 1 score, we could have 100 scores, we could, you know, it will give us the average result. What we need to do is now convert this into function format. So let's grab that and happily go over to our formula screen and start to actually write out this function. So we're going to say func average scores. But immediately, if we just dump our thing for reference in here, immediately we find that we might be in a tricky situation, because what we've got here is a list of potential types. We've got floats, we've got booleans, we've got colors, we've got dates, but what we want to put in is something that looks like this, something of that shape. And that's not defined by any of these types that are available to us here. So what do we do in this instance? Well, this is where another feature of Power Apps comes into play. That's user-defined types. So not only can we define our own functions, but we can also define our own types. And this is what's going to allow us to create these kind of more complicated functions where the shape of the input is not just a standard number, text, boolean. It's something specific to your data, or it's something of a more complicated shape like we're seeing here. One thing that you might need to do, depending on when you first started your app, in order to use user-defined types, it is in the new feature set, so it's not a preview feature anymore, but you might need to turn on this setting. So just a heads up, if you find that you can't you follow this along and create your own user-defined types, just double check whether you've got that setting. And as with the user-defined functions, unfortunately, there's no real nice, documentation from Microsoft about how we actually structure these. So I'll just give you what the syntax is supposed to be. And from there, we can then create our blueprint. So syntax for a user-defined type, what you need to do is give your name of the type. So I like to start it with TYP to denote this is a type. It just helps to kind of group in and let you know this is a custom type that we've created. And then rather than just saying equals, because that is the syntax that is used for named formulae, instead what we do is a colon and then equals. And again, we can kind of remember this in our minds by associating that colon symbol with data types and defining the type of something, as we saw you know, in our function blueprints, we're saying, okay, this is the input name and colon, this is the type that it has to be. So we associate colons with types. And then the last important thing is we need to give it a use the type function so that we're saying, okay, this is now our definition of our type. So that's just unfortunately like how something we need to remember in order to create these user-defined types. But as soon as you've got one in your application, you can always use that for reference. So let's pop that in there, and let's just, so we don't get errors, comment that out so we know, okay, that is exactly the syntax that we're supposed to be using. So for us, we want to define two types here. We're going to define a score, which is this score object, and then a list of scores, which is the list of the score objects, which is actually what we want to put into our user-defined function. So in order to do that, again, we type in the name, we do the colon equals, use the type function. So just following along the syntax, this is what we need to type. And now we're going to basically write a blueprint for this object. Well, the object starts with a score column, and then the type of data that we put into that score column is a number. And following that on, obviously, we've got a max score column, and the type of data that we're putting in there is a number as well. Now, if we do type list of scores, we'll use the exact same syntax. We've got our name, colon equals type function, and we're going to just do an array of type score. And notice Power Apps has recognized this is a potential type that we can now use. So we can basically tell that that's worked perfectly. And now what we can do is start to write our function for our average percentage, average scores, sorry. So we pop in our past scores, and now let me just, instead of dashing away from it, we'll open up the colon, and we can see that instead of just having the standard list of available types, we now also can put in either a type score or a type list of scores. Perfect. We know that we need a list of scores in here, and we know that our function is going to output a number, and we know that our code to actually make this work is going to be this bit here. So obviously it's freaking out at the minute because it's expecting this with scores that we used. So I'm just going to change those to par. And what you might find if you prefer is when you're prototyping these functions, rather than calling it with scores, you could call it par scores, because it's going to end up becoming a parameter, input parameter. So now we have our function that works. It's calling another function inside of it. So our user-defined functions can, not only can we chain them like we saw earlier where we did func format percentage, and then inside we passed in a value that was calculated by a formula, we can actually chain them within each other. So this function average of scores calls the function convert score into percentage actually within its code. So this also means that wherever we're calculating an average is automatically going to update. If ever we need to make a change to func convert score into percentage, we're not just affecting everywhere where that function is used in our application, we're also affecting everywhere where our func average of scores is used in our application. So this is kind of the power of it, where you can reuse these things in so many different places everywhere in your application, and in a singular place you can update it, make improvements to it, and that will just cascade throughout everywhere without you needing to remember where did I use it? Have I, copied and pasted everywhere? Trying to use the search functionality to find any instance where you could have referenced it. So now what we can do, again, we've made that change to our function. Let's actually test that it's, like, double check that it's working in our application. We're just going to comment out the existing functionality and replace it with func average of scores. We can see that it's looking for past scores, and we can just give it the scores that are available to us. And of course, this could be, rather than it being like this, it could be a collection, for example. So it could be a lot easier to, drop this in rather than having to specify, each particular score. You could, if you've got a collection that's got all the scores, then you can just put that in here and have a single line argument. So I noticed that we're coming a little bit close to time. So what I'll do is I'll just quickly run through some of the other things that I wanted to share with you today. Oh, and firstly, we'll just actually double check. Yes, this works perfect. And as with the other, we can do we can wrap this in our func format percentage, and we can see that that is actually outputting with the percent sign. What we could do as well in that func format percentage is we could say, for example, wherever we want our numbers actually being displayed, we want them to be displayed with, like, rounded to the nearest 2 decimal places, for example. So we could do something along the lines of this. And then that will, force this for all of our percentage values that we're formatting with that function. They will automatically go down to the format that we are intending. So this is, a really powerful thing. You can see it's affected all of the percentage values that we've got. They've all automatically been adjusted to that. So if you ever wanted to change the format for, like, across the board, you can do that in that one function location. So one thing that we haven't touched on yet, which I just want to quickly touch on, is so far all of our functions have actually outputted a value. They've spat something out. You've fed it something, it's done its work, and it's actually provided an output. But not all functions work that way. For instance, obviously, everyone will be very familiar with the navigate function. That doesn't give us a result. It doesn't return, a value. It doesn't perform a calculation in that sense. What it does is it affects the application. So what we call that is a behavioral function. And what you can actually do is you can create behavior function, like user-defined functions as well. There's just a slight difference for this. So let's do a func behavioral function example. And for this, I will just not put in any inputs, because you don't actually have to put in any inputs. It's the same with the, and that's not just the case of behavioral functions. You can have that for our, our other functions earlier on. If we didn't have any variable like components within the calculation, then we could just do it as a function that doesn't take any inputs. But what we still need to do is define an output type. And this is, obviously confusing, because we're in a situation where, we're not outputting anything. So how do we know what type that is? And that's where this special type void comes in. And you'll notice that when we, are trying to put the inputs in, we don't have the option of void here. Void is essentially just, it means I don't exist. So we can't, rather than creating input parameters that have a shape of not existing, what we do is we just don't add the input parameters, because that's the way that it makes no sense. But in order to say this doesn't output anything, we have to use the output type of void. So that's the first kind of key to your behavioral functions. You have to make sure that the output type is void. The next thing that we need to do is we need to put whatever logic we want this function to perform in curly brackets, and then obviously close off with our semicolon. And the reason why there has to be some curly brackets here, rather than just, where before we just said, perform this logic and then semicolon, that's the end of the function. Well, in behavioral functions, you could actually do multiple things. You could say notify hello world, and then the next thing you do is navigate to the reference screen. And so how would Power Apps know whether, if we consider removing these curly brackets, how would Power Apps know whether this is the end of the function, or whether this semicolon means do this and then do another thing within this function? So that's why you need the curly brackets there, is basically to say this entire block is a list of steps that we want this behavioral function to be able to perform. And if we just put in a quick button to test that, we can go behavioral function example. We know that it doesn't take any inputs. We press the button, we go over to the reference screen, and it gives us a notification of hello world. So that's just an example of how behavioral functions work. What you generally would use them for is things like manipulating collections, creating collections. So if you are, every time you refresh your data, you're recollecting down the information and manipulating it into a certain format. That's often quite a complicated and hefty piece of code, and you don't want to be copying and pasting that around everywhere and potentially missing a location and then having your collection schema not matching what it expects. So what you would prefer to do in that instance is create a function instead. So just as we get towards the end, I just want to show, obviously we've just looked at some quite simple examples, but kind of like how you can push the limits of this and what kind of things you can achieve by using functions that would be very difficult or would require a lot of that kind of copy pasting if you were to do it without user-defined functions. I think one of examples of that is this is a line chart that I've created within Power Apps. So this is using SVGs to dynamically create these lines. And we can see we've got some cool functionality here. So like if we remove count 5, which has the highest value, then the graph actually, the Y range shrinks to accommodate so that it's not just using lots of blank empty space at the top. Similarly, we can see we've got some filtering that we can do on the dates. There's lots and lots of different functionality kind of like embedded in this component. And all of that pretty much all of that functionality is driven by user-defined functions. So if I come in and show you all of like how this is built and how this actually works, if we come in and have a look at the image itself, you can see the first thing that we're doing here, right? We've got Ymax here is using a function to calculate, okay, this is the maximum Y that we would have for the data that we're trying to show. Again, we're using a function to calculate Y delta. We're using a function to calculate Y unit. This is actually a function that is essentially separating out that safe divide that we did here. So for example, we would have utils safe divide. Our dividend is our number. Our divisor is a number. And and we are outputting a number, and we're always wrapping in if error, so par dividend over par divisor. So in any other situation where you would need to safely divide something and not cause that error message outside of your converting into a percentage, you can use that util safe divide, and then obviously we would be able to replace this part with a reference to this function here. And as we go through it again, you can see there's just so many function calls in here. And when we're actually drawing the line segments, because this is quite a complicated, and you can see again this kind of with prototyping, first of all I wrote the functions, or wrote the functionality in here so I could see exactly what was going on. I could see the lines being drawn as I was writing the code, and then once I understood, okay, this is exactly what I want to do, I now need to either copy and paste that for every single line that we're drawing here. We've got obviously 6 counts in this particular one, but you can extend that to however many you want. Instead of copying and pasting that logic and then needing to make sure I change it in 6 different places in this code, I created a function to be able to do that for me. Obviously, this function, it's got quite a lot of arguments, so it can look quite intimidating that we've got so many input parameters. But this really simplifies things, because when I initially did it, have the little dot markers or X markers, and then I was able to add that functionality, and rather than, as we say, making sure to paste that in every single location, it just automatically was coming across. And there are other things in this component that are also using those same functions. So you can see here again, we're using find max y to use the y max, find y delta to use the y delta. And obviously, if you were looking to just be able to show one line chart across your entire app, then you might be able to simplify this instead by creating global variables that would store your y and like max y and y delta and things like that, and make sure that when you're changing things like the filters, you're recalculating that global variable. But first off, that means you need to make sure you recalculate that global variable at all times, which can lead to misremembering that you have to do it, and then bugs getting introduced. And on the other side, that limits you to only having one instance of the graph on screen at any one time. Using these functions, because the actual controls themselves are calling the functions, I can present however many of these line charts on the screen at any one time. And that's, a really kind of powerful use case, in my opinion. So what I'll do is I will stop sharing and actually stop the constant stream of talking for you guys. Hopefully, Luke, if you could bring up the slides for the next session, because obviously tomorrow we have the amazing Leslie Kirk, I believe, showcasing the Copilot adoption. But also, if there's any questions or anything, I am more than happy to field those.
Thank you so much, Clarissa. That was a lot of content. And I like how it got big and you're like, this is really small. So yeah, really great. And I think those kind of things can get really complex. You go down a rabbit hole, and like you say, as long as you can then simplify afterwards and have the reuse, really powerful stuff. So thank you very much for talking us through that. We did get a question, but it was, can I get this on YouTube afterwards? Which of course you can.
Yes.
I guess we're probably going to want to watch and work along with you, which would be a great way to learn how to do all of these functions. And I mean, that's really powerful stuff. So thank you very much spending your time with us this morning and for passing on so much knowledge. I know everybody here completely appreciates it. So thank you for that.
Fantastic.
We
Thank you very
don't
much. I do
have-
apologise for the technical difficulties halfway through.
That's okay.
Hopefully that wasn't too intrusive.
When we've had a chance to chop that a little bit out, when we've had a chance to pull all this together, then it will appear on, if you look for the Sharon Sumner MVP or just search for SharePoint Sharon on YouTube, you should be able to find me, and that's where we're hosting all of the videos from this session. So thanks again to Clarissa for a fantastic workshop and a really productive morning in understanding and reusing variables. So thank you very much. As Clarissa said, tomorrow we have the lovely Leslie Crook coming along to talk to us about Copilot adoption. It's really important to get adoption right with every single technology. We've all lived through it with Power Platform adoption in every guise. All of those individual workflows, Power Apps, Power Automate, and Power BI all require careful handling. AI is no different. It's not a drop it and watch everybody use it kind of technology. We need to consider adoption, and we need to look at how that's done sympathetically so that we don't get change fatigue and all of those frustrating user feedback, so that it can become part of the organization and really useful to us. So we'll be covering that tomorrow and continuing our spring sessions in 40-degree UK heat, which is more like an Indian summer, but hey. And again, thank you, Clarissa, and we will see you on Friday back for the panel roundtable on women in tech. So thank you very much for coming along. Thank you everybody for attending, and we'll see you tomorrow morning.
Thank you, everyone. Bye.